The Finley Holiday slide cassette program that you are about to see and hear is the first of its kind ever made available to the public. And it is a new high in audio-visual entertainment for people of all ages. It's very simple to use. Please follow these instructions. First, place your 40 slides in the projector and move to slide 1. Then, each time that you hear the tone, advance the slide. It's as simple as that. So now, sit back and let's enjoy the show.
There has been life on Earth for over 2 billion years, and man himself has existed here for at least 1 million. Yet it is no more than 15 years since life has emerged out of our atmosphere into outer space. Historians 1 million years hence may well regard the middle of this century as the turning point of earthly life and of our own species. America's space program today stands on its own feet, an heroic manifestation of the vital evolutionary progress of man toward a higher and better life. It is justified by its success to date, by its promise of continuing success in the future, and in the enlargement of human knowledge of the universal environment in which our spaceship Earth travels. Its accomplishments to date are marvelous, bordering on the incredible. From a humble, sputtering beginning, man has progressed to today's mighty Saturn V rocket. Many years ago, a figure quite familiar to most of us today came upon the scene. His name, Buck Rogers. The younger generation of 4 decades ago were engrossed with his escapades in the future. So, that younger generation grew up, and using the example that Buck had shown them, designed and built their way into the future. For instance, he predicted men would fly around with little jets strapped to their backs. 40 years later, we are doing just that. In 1932, Buck predicted atomic energy and its use for producing electrical energy for mankind. Today, we have it. In 1936, Buck and Wilma explored the moon, and in the dim light, they thought they saw something move. Since July 20th, 1969, that movement could have been American astronauts. 5 centuries ahead of Buck's prediction. In 1903, man, for the first time, using generated power, flew away from his planet. Orville Wright flew about 20 feet high, and he traveled about 200 feet before returning to Earth. His journey lasted 12 seconds. Today, 70 years later, we have reached the planets. Who is to say how soon before man reaches the stars? Some believe that this is man's destiny, his ultimate purpose. Until that day arrives, he will remain restless, always searching, exploring, expanding against the unknown. For such is his nature. Many say that this should not be, that the money spent on space should be spent right here on Earth. They are quite honestly wrong. But other great people have been wrong, too. Daniel Webster once said, "It is a waste of taxpayers' money to explore west of the Adirondacks." Later on, we will show you just how wrong the critics of the space program are. But what about today? Where are we in space exploration? What does the immediate future hold? The point of this nostalgic look at Buck Rogers was to show you just how much we have condensed the technology of the future into the past 30 to 40 years. Hopefully, that brief journey into the past will prepare all of us to accept the fact that the next 30 to 40 years will witness far greater projections into future technology and space accomplishments. What has space exploration and the vast wealth invested in it brought to the average man and woman? We shall see. You are all aware of the amazingly successful Apollo program, a program that has been called the greatest technological achievement in the history of mankind. Yet there are people, important people, that scoff at Apollo as a waste of good money. Until Apollo, we honestly had little background for space. We had to produce an almost superhuman effort to develop materials and technology that we knew little about. So we entered a period that is best termed the age of space exploration. Not only exploring space, but also the technologies of the space industry itself. With the Apollo lunar landing program completing its task in December 1972, we are at last ready to enter the golden age, the age of space exploitation. If you look up that word in the dictionary, you will find it means to make use of. That's where we stand now, ready to use the knowledge that we have gained in space to even a greater degree than the past decade for the benefit of all mankind. The first step is the program called Skylab. We have modified the third stage of the Apollo 5 launch vehicle and transformed it into an orbiting laboratory. A laboratory in which men perform experiments, all aimed at benefiting the Earth and those on it. 3 separate man crews, staying up as long as 56 days, will spend most of their time studying ways to benefit Earth. The next major program will be the Apollo-Soyuz test project, ASTP, which will find an Apollo spacecraft docking with the Soviet Soyuz. Crews will be bilingual and actually will spend time in each other's spacecraft. There are many important tasks to be accomplished here, but none as important as bringing together 2 former antagonists for a venture in peace. After this program, we will be ready for man's first real step toward the stars. It is hard to exaggerate the importance of the space shuttle to man's future in space, and for that matter, perhaps his survival on this planet. For this is the vehicle man will use to jump 1,000 years into the future. Scholars someday may look back upon the first flight of the space shuttle as the beginning of true space travel. So what is the space shuttle, and what does it mean to our nation and the people of the world? The space shuttle, which will be operational during the 1980s and 90s, is a reusable vehicle. Its orbiter might best be described as a space truck. Really, that's its main purpose, to transport cargo or personnel from Earth to space. With it, we will have ended the building, probably forever, of huge one-use booster rockets. For with the shuttle, many projects will be assembled in space. A key feature of this space truck is its enormous cargo bay. Remember that the shuttle is not small. In fact, it is far larger than any spacecraft ever built. The Apollo command module is tiny beside it. The cargo bay is 60 feet long with a 15-foot diameter. This compares in size to the passenger compartment of a 747. It is in this compartment, or cargo bay, that the space truck will carry its large payloads into space. The greatest expenses of the space program have been the launch costs and expendable spacecraft. With the shuttle, however, there will be a tremendous reduction in the cost of America's space program. The rough estimate is that the cost of launching each pound of space cargo will be reduced about 90%, from $1,000 to $100 per pound. In order to give you a better understanding of how the shuttle works, let's follow a projected launch and performance of this craft that holds the key to man's venture into space. Actually, the shuttle orbiter is a space airplane, which is capable of more than 100 flights to space and back. It will be launched in a vertical position as a rocket. The orbiter has 3 main engines. Each of these develop 470,000 pounds of thrust. Fuel, liquid hydrogen and liquid oxygen for the orbiter engines will be carried under the belly of the shuttle orbiter. Strapped to the external tank are 2 recoverable solid rocket motors which will assist in boosting the shuttle from the launch pad. These solid propellant motors generate 4 million pounds of thrust each. After liftoff at about 23 miles, the 2 solid rocket motors will have used all of their propellant and will be jettisoned. Then they will be brought back to a pre-selected landing site by parachute. The shuttle orbiter, meanwhile, continues on its own power to climb to approximately 125 miles, where the giant belly tank is jettisoned. The orbiter then stays in Earth orbit for a nominal period of 7 days, performing a multitude of tasks. A primary purpose of the shuttle will be to place satellites in orbit. Using the huge cargo bay, which is capable of handling even the largest projected satellites, we will carry them up to orbital altitude without the use of those expensive boosters. The United States is at least a decade ahead of the rest of the world with the shuttle, and we are already having many serious inquiries from other nations that wish us to launch their satellites for them. Eventually, these launchings could produce a profit bonanza for the United States. Most satellites today have a fairly short life expectancy. Think of the huge savings the shuttle will produce. For instead of this vast waste, the shuttle can bring repair crews to them or bring them back to Earth for extensive overhauling. Space-age technology is moving so fast that today's best part may be tomorrow's antique. Shuttle crews can replace outdated parts with modern, up-to-date new ones and install new systems, thus prolonging their usefulness to infinity. Many satellites require a synchronous orbit to stay over the same part of the Earth. That means that they must go up to at least 22,300 miles. Using the orbiter cargo bay as a launching platform at several hundred miles up reduces the tremendous propulsion power needed to get them into deep orbit and dramatically reduces the cost. The payloads that can be used with a shuttle are limited only by size, weight, and man's creative imagination. The day is not far away when fully equipped laboratories, manned by leading scientists and engineers, are placed into orbit. Such research that they conduct could revolutionize medical and manufacturing techniques. Keep in mind that these people, including women, will be able to work in a comfortable shirt-sleeve atmosphere. Virtually anyone will be able to go into space. Later versions of the shuttle could be space liners that will travel from Earth to hotels, factories, or even cities in outer space. Another very important aspect of the shuttle is that it can be easily outfitted as a short-duration space station. The orbiter could be equipped to stay in space for 30 days, constantly monitoring the entire surface of the Earth for such programs as air, water, and ground pollution monitoring. Eventually, probably during the next 20 years, we will build a true space station. The first studies are already completed. Using a modular concept, so designed that each module would fit into the cargo bay of the shuttle and would be carried aloft one by one until the station was complete. In stations such as these, men will live, constantly watching our Earth for problems or dangers. Once the mission is completed, the orbiter goes out of orbit, re-enters the Earth's atmosphere, and lands on an existing 10,000-foot runway as an airplane. It is then towed to a maintenance hangar, given an airplane-type refurbishing and cleaning, and 14 days later, it is ready to go again. While there are still doubters among us today, fortunately, most people have the capacity for looking further ahead. Many of the shuttle opponents want the money used for space switched to Earth problems. But just what are those Earth problems? Let's take a look at just a few examples of what the space program has provided in those so-called problem areas. And keep in mind that these are not the reasons for which the space program was originally created. Take air pollution as a start. Space photos have shown air pollution over Los Angeles proper, and also pollutants pouring out of the San Gabriel River into the Los Angeles harbor, as indicated by the white streaks in the ocean below the coastline. But air, water, and ground pollution are never local or even national problems. Global monitoring and warning is the name of the game, and for that, we must get our view from space. The point is, what would take airplanes on a global basis 46 years to monitor in pollution, a shuttle laboratory could monitor in just 18 days. Do you realize that mankind's greatest killer is not heart disease, nor is it cancer? It is famine. Space could help us lick this horrible problem. Here's an infrared photo. Anything living containing chlorophyll shows up red. You see here the farms of the Imperial Valley of California. From this same photo, the degree of redness can be measured, and we can tell what kind of crops are being grown, whether the crops were young or old, healthy or diseased, and even estimate the yield. Now, if we could know all of this on a global scale, we could estimate what crops the world would produce for the coming season, where and what kind of fertilizing was needed, whether the crops were healthy, and if the production would not be enough to feed a country, or the world for that matter, we could find new or other areas where additional crops could be grown, hence a possible end to famine. From space, we will be able to measure the depth of snow on mountains, estimate how fast it will melt, predict how the water will flow. We can locate perfect sites for dams. We can help solve the energy crisis by finding new, clean power sources, some in space. But one such power source is geothermal power, water heated in the Earth. This huge potential under the Earth is virtually untapped. From space, we can easily locate these great pockets, the type of power that causes geysers and volcanoes, and speed their development by many years. One of the greatest areas to benefit from space is the field of meteorology. Just thinking back to the most recent hurricane warning should be enough to show us the advantages of better weather forecasting. Think what accurate weather predictions will do for the farmer in crop planning and harvesting, for the construction industry, or even for John Q. Public in planning a picnic. Well, those are all rather large areas of benefits, right? But what has space done for us lately? What we might term see, touch, and feel benefits. Let's look at just a minute percentage of some of the more obvious. For instance, because of that tragic Apollo fire long ago, we now have several new types of cloth, beta and durette to name just a couple. We now have clothes, blankets, drapes, materials worn by firemen. They all have something in common. They will not burn. How about a gasoline auto tank that will not catch on fire after a crash? A non-flammable paint that literally puts out the fire when it comes close. That's already here and called Laticoat. Or how about a rocket torch with a solid fuel that cuts through 3/4-inch steel at the rate of 3 feet per minute? If you're a sportsman, you probably would appreciate a new type blanket, the size of a cigarette pack, made of the same mylar used on the Echo satellite and weighing only 3 1/2 ounces. Medical benefits are myriad. They literally number in the thousands. They range from a revolutionary electrocardiograph electrode to an adaptation of a manipulator arm for the paraplegic, which enables the patient to write, put on lipstick, and eat. The future offers projects, accomplishments, and benefits so enormous as to be almost incomprehensible. We will have space cities, space hospitals, space factories, space hotels. We will have a generation of people born and raised in space saying, gee, that Earth is a great place to visit, but I sure wouldn't want to live there. All of these things, as important and far-reaching as they are by no means the most important. Even today, a new feeling of common interest, of common hope, of vast new horizons toward which man can set his goals are being developed between nations. Yes, today, even more than when good old Buck Rogers said it 40 years ago, what is hoped for, more than any other benefit, as a direct result of space exploration, is international, everlasting peace. Your bi-media program is now complete. Please rewind this tape and you will be ready to enjoy it again at your next showing.